VLAN Layer 2 configuration. Believe it or not, VLANs themselves are pretty simple, both in concept and in configuration. It's all the other network technology around VLANs that makes them complex. Tagging VLANs, routing between VLANs, subnetting in VLANs, quality of service in VLANs, spanning tree in VLANs. I mean, when you start integrating all those things, it just can become overwhelming. So what I decided to do was break down VLAN configuration into multiple nuggets, going one step at a time. This one going into layer 2 configuration. Now, if that terminology alone is confusing, don't worry, I'm going to break that down more as we go into this nugget, but we're going to start off with GNS3. I even underlined it from the beginning. I've gotten so many emails and questions from students and people getting into the Cisco world saying, hey, can I do something with switches in GNS3? Can I emulate VLANs? I really want to learn this. How do I do it? Etc., etc. Yes, it actually is possible, and so I wanted to add a special piece right from the beginning of this nugget showing you how to build a topology in GNS3 that can be used to simulate and emulate VLANs for your configuration. So if you know how to do that or you're not interested in that, just fast forward right past it. You'll be able to tell when the graphic switches to a switch topology that I've gotten it directly into the VLAN configuration. Let's get started. Well, I just opened GNS3 and saw this message come up, which is great because I was actually going to talk about this. GNS3.net is the people who created this, just completed their crowdfunding campaign, which they set a goal of $38,000 to try and raise for future development of GNS3. Guess what they got? Close to $300,000. Seriously. And what's funny is GNS3 is actually a couple of 20-year-old guys who I'm sure are like, woohoo! You know, they're on a yacht in the Caribbean right now or something. I don't know. I'm sure they're handling all those donations very responsibly, right? But nonetheless, GNS3 1.0, the big feature it's supposed to add is the support for Cisco switches to where you can manage them. So some of what I'm going to show you may be, I'll say, obsolete by time when you get there, but the premise will be the same of how to do the virtual PCs, etc. So let me go into this, and I'll tell you what may change when we get to 1.0. So new project, we'll just call this GNS. How about GND? GNS3 demo. I'll save the NVRAM just to make sure I don't lose my configuration. Hit OK. Yeah, that's fine. So I'm going to come up here and bring the routers in the picture. Now I've added the iOS for a Cisco 3745 router. So let's bring a couple of those onto the landscape. Now you might be thinking, I thought we're doing switching. We are. 3700 series as well as the 3600 series has support for what's called an ether switch module. So I'm going to come in here and hit configure, router 1, slots, and slot 1 I'm going to throw in a 16 port ether switch module. Did I say ether switch or Ethernet? Ether switch module. To where it essentially adds a 16 port switch to that router device. Now, just for grins, I'm going to come in here and change the symbol because I just like looking at it better if it's a switch, and change the host name from R1 to switch1 because that's really what I'm going to use it as. Now, GNS3, the people who created it were smart. Matter of fact, so smart they raised almost $300,000. That they actually allowed you when you change the symbol to a switch. And I'll just change the host name as well. I think you just change the symbol, and they automatically add, once they see you doing this, they add the 16-port ether switch module for you because they're like, I see what you're doing. Right? So now we have two routers that will pretend that they are switches. Now I'm also going to bring a host onto the scene. Now this is actually known as a VPCS. Device. It's a virtual PC simulator. The beauty of this, at least for the Cisco world, is that this device is essentially a command prompt that allows you to do ping and allows you to do trace routes, which is virtually all you really need to create a GNS3 lab environment, right? So I'm going to add a couple hosts over here. Then we're going to go into the manual configuration connection. So I'm going to come to right here, which is going to be the connection. A lot of times for the ether switch module, you'll have to go manual. And we'll say, I'm going to connect from now. Now notice right here, we actually have a number of ports. These are the built-in router ports, Fast Ethernet 0/1 and 2. All of these, notice they all start with Fast Ethernet 1/something, right? These are the 16-port ether switch module. You can see the numbering going from 0 all the way down to 15. That's going to be what I'm using, so I'll connect on here from, let's go Fast Ethernet 1/6, just because it'll match the graphic I'm going to show you in a moment, over here to Fast Ethernet 1/6. So we've got those guys cross-connected. Then I'll come down here and connect Fast Ethernet, let's go 1/1 to computer 1. Now, looking right here, you're going, what is all of this madness? Well, what the virtual PC simulator does is actually use some trickery with UDP ports to open a connection from a command prompt behind the scenes into this environment. I'll show you that in a second, but truth be told, only thing you have to know is that you can emulate 9 virtual PCs per topology, right? Which shouldn't be a problem unless you just have a huge topology. So I'm going to connect the first one here on that port 0. The connection over here will go from fast Ethernet 1/1 down here to 2000 or 20,001. Essentially, that's the port that we're going to use. Now, that's all fine and dandy. I'll power on the 3745 routers and get the hypervisor starting behind the scenes. But in the meanwhile, I'll also open a command prompt and show you on here how to get to these virtual PCs. Initially, it's a little confusing because you come in here. Hang on, let me turn off my connection. Come in here, you're like, okay, I can configure, add a link. How do I actually open the command prompt? Well, it's a little tricky. You have to go into a command prompt itself on your Windows PC. I'm going to change directory to program files /GNS3, right? If I do a directory listing, now I'm working on Windows. Linux has a little different way of going about it. But essentially, get into the GNS3 directory. I'm also assuming that you've downloaded the full GNS3 package, haven't done any funky source code compiling or individual installs. Inside of there, right? Disclaimer aside. You see this little command file called VPC's start. You hit enter, and bam, I'm sitting there in VPC Virtual PC Simulator number 1. This matches up to the first port that I matched to. So essentially connects to computer 1. Over here is computer 2. Now, inside of here, I can do the configuration. As a matter of fact, I'll hit question mark. You can see it's very limited. I can do ping, trace, which is really where I'm at. That's the 2 that I'm going to use. And then IP, how to assign an IP address. Well, the way we do it is we type in IP followed by the IP address we'd like to use. In this case, I'm going to do 192.168.1.50, right? Followed by, now this is, you can use the question mark to try and learn this command, but I'll help you out. You type in the default gateway, 192.168.1.1, we'll just say it's the default gateway to get off the network, and then how many bits are in the subnet mask? I'll say 24, right? It's checking out there for a duplicate address, making sure it's not assigned, and boom, just like that, PC1 has that's this guy right here. PC1 has the IP address 192.168.1.50. Now, how do I get to PC2? Type in 2. That's it. You can see right here it's gone to VPC simulator number 2. Now I'll hit the up arrow and say let's make this guy 51, and bam, I've now assigned an IP address once it comes back to PC number 1. PC number 2. So now I've got 2 PCs with these 2 individual ports. I'm guessing, I haven't tested this yet, but I'm guessing I'll be able to ping from 192.168.1.50 to 51. Now notice I did 1, so I flipped back over to PC number 1. So 51, hit the enter key, and sure enough, I'm getting pings. Now the beauty of this is awesome because it's actually going through my Ether switch module. So I'm not only testing my VPC connections, VPC simulator connections on C1 and C2, but I'm also verifying that the Ether switch modules are linked up and they are working on my 3750s. Hop over to PC number 2. Of course, I'll be able to ping myself. You can see lightning speed on that. And then I can go over and say I'm going to ping PC number 1. Right. Last thing I want to show you, and this is getting into some of the configuration I'm about to do on VLANs. I'm going to come into the router itself, and let's open a console connection to this. So this is my 3745 router. Show IP interface brief reveals that I have 1/1 that's connecting to the PC, which is up and running, and then 1/6, which is my cross connect, right? And I can come in GNS3 and click that button, show all the connections that are coming in and to the different places. They are actually showing up, but the big one down here is VLAN 1, right? So I'm going to come in here and do config T, interface VLAN 1, and let's make this guy IP address 192.168.1. What did I make these guys? 192.168.1.1, right? 255.255.255.0. Just like that, we now have VLAN 1 configured. Essentially, the swouter, the switch inside the router, is going to be the default gateway for these 2 PCs. So I can now come over here and do a ping to 192.168.1.1. Now, I'm always the cynical one, right? Cynical? No, skeptic. Thank you, Jeremy. Skeptical one. That I'm like, okay, is this just like a show? I mean, is this virtual PC just like giving you success with everything, and it's not really pinging a different device? It is, and I just for the cynic at heart, cynic. I don't know why. Skeptic. I don't know why I'm confusing those. So I'm pinging 192.168.1.2, right? Notice it's failing. It's not just a little emulator. I'm going to come up here to my router 2, bring open a console port, and do the same thing. Config T, interface VLAN 1, and let's give this guy IP address 192.168.1.2, right? IP address I just tried to ping and found that it was unavailable. So I come back now and hit the up arrow. 2 wasn't available before, and now it is because we have live devices. Okay, good. So this should give you a good feel of how you can set this up in GNS3. Now we get into the good stuff, the VLAN configuration itself. First off, take a look at the topology. This is a logical view of the topology I just created in GNS3 previously. I've got 2 switches, represented by Ether switch modules, connected on Fast Ethernet 1/6 on both sides. The computer is connected to Fast Ethernet 1/1, right? And by doing the illustration that I just did when I showed you how to build this in GNS3, we saw that we are able to come in here and assign this guy. This guy's 192.168.1.50. This guy's .51. We were able to ping between them. The router itself, or we'll call it Ether switch router itself, we gave the VLAN 1 interface the .1 on this side and the .2 on this side IP address, and we were able to ping to 192.168.1.2.50.51, essentially verifying that these things are working just like switches, like they should, right? So now let's add the VLANs on top of it. I'm going to go to switch 1 on the left, go into global configuration mode, and the only required element to create a VLAN is the VLAN ID. The way I do that is typing in VLAN followed by the number. So let's just say I'm going to create VLAN 5, right? Now, it is a good idea. You can see step 2, not required, but a very good idea to name the VLAN. If you don't, let me just do a show VLAN. And actually on Ether switch modules, it is VLAN-switch. Normally on a real switch, it'll just be show VLAN. Same difference. So I'm going to type in show VLAN switch, and you can see that I've got VLAN 5 represented by the name VLAN 0005. Right? Not very intuitive. So I'm going to come in here and name it after the department that it belongs to. We'll say the name of this VLAN, and we're in the service provider series, right? So let's just call this DSL customer 1, right? Just for the fun of it. Exit out of there. Let's do VLAN 10, name DSL customer 2, right? Exit out of that. Now, as I do a show VLAN-switch, I'm able to see these 2 DSL customer VLANs showing up. Now, here's where it gets kind of fun. So I'm sitting here on VPC number 1, right? So this is the left computer, and I'm going to ping over to the right, 192.168.1. And actually, let me just verify. Ping question mark. Good. We've got the -T argument on this virtual PC simulator. So I'm going to do ping 192.168.1.51-T so that it'll just keep on pinging. We can actually see this in action, right? So I'm going to pin that guy up on the screen. Switch 1, I'm going to go into global config mode. Let's go into interface Fast Ethernet 1/1, which is where this PC on the left resides. This guy right here, right? And I'm going to do, first off, switch port. Hey, let me do a show run section interface. Oh, that wasn't what I was hoping to see. Oh, actually it was. This is the interface sections. Fast Ethernet 0/1/0, showing that essentially there's no configuration under it. Now, older switches, and when I say older, I mean a couple years ago and before, use switch port mode dynamic, which is scary. It can switch back and forth between access ports and trunk ports. We don't like that. So when we're under the interface, I'm still under that interface Fast Ethernet 1/1, I'm going to type in switch port mode access. What that means is essentially this port will only access one VLAN. Now, as of right now, that's going to be VLAN 1. That's what it's assigned to, until I type in switch port access VLAN 5. I'm hitting the enter key. Ready? Check out what happened to the pings above. As soon as I did that, it now started timing out. Why? Because I've completely segmented this into a separate network altogether. This guy is 192.168.1.50, right? That's his IP address. But he's isolated, meaning he's trying to send ARP messages out. He's saying, hello, who is 192.168.1.51? That would be this guy hidden behind my prompt right here, this guy. But this guy over here, this is in VLAN 5. This is in VLAN 1. He's in a totally different VLAN. He no longer gets that ARP message. He's essentially, I'm in a different network than you, right, is the essence of 51. Now, let's try and remedy that, right? So we've got this guy switched over to VLAN 5. Have I been saying VLAN 50? For some reason, I keep getting the IP addresses. It's VLAN 5. I've been saying that, right? So what? Can we just go over here on switch 2 and add that PC to VLAN 5? Well, let's try out. I'm going to go to switch number 2, bring him up in the picture, and we will go into global config mode. We'll do VLAN 5. We'll name this guy DSL customer 1, right? Exit out VLAN 10, right? For some reason, my brain is just not there. Do show VLAN dash switch. VLAN, yeah, DSL customer 1. VLAN 10, just the number has to match, not necessarily the name, although it's great practice to, of course, have the same name. So I've created both those VLANs now on switch number 2. Again, I'm seeing my pings fail. Okay, switch 2 is sitting there. I need to assign this guy, right, this .51 guy, who's currently in VLAN 1. I'll prove that right there. We've got fast Ethernet 1/1 sitting in VLAN 1. I need to move him to VLAN 5, right? So I'm going to go in, interface fast Ethernet 1/1. We'll do switch port mode access, so it's assigned to only one VLAN. It's an access port. Normal devices are that way. And switch port access VLAN 5. Enter. Okay. So I go back and do a show VLAN dash switch. What's up with that? We've got these guys both in VLAN 5 now, right? So I can scribble this guy out of here. VLAN 5 on the left-hand side. Now, how come they are not able to ping each other as of yet? Well, we can't forget about this red line in the middle. Now, what VLAN is that a member of? VLAN 1, right? This one needs to be defined as a trunk port. A trunk port capable of carrying more than one VLAN. And essentially, by default, a trunk port will carry all VLANs between the two sides. What's happening right now is this guy on the left is trying to ping the guy on the right, and it's going, hello, hello, VLAN 5, and the switch right here gobbles it up, chomp, because it's seeing that this port isn't a member of VLAN 5. Now, in order to carry VLAN 5 along with VLAN 10 and 20 and 50 and however many VLANs that we add to this link, we have to use a trunk port, and we have to add these VLANs as tagged. Normal ports, access ports, are untagged VLANs, meaning these guys are just a member of. We don't actually get packets coming out of here that tell this computer what VLAN it's a part of, because the computer itself doesn't know. It doesn't care that it's a member of VLAN 5. It's just a computer. Plugs in, gets an IP address, knows how to talk on the network. That's what computers do. VLANs are a switch thing. So as we move packets between switches, that's where we have to tag them so that this switch 2, knows which VLAN it belongs to, because as of right now, we're not doing well. So I'm going to come over here to switch number 1, and I'm going to go into interface fast Ethernet 1/6. I'll do switch port mode trunk, right? Hop over here to the other side, switch 2, because they are cross-connected on. Look at that. It says I'm blocking fast Ethernet 1/6. I've got an inconsistent port type. We're not doing well because it says one side's a port, the other side's access. Things are broken. So I'm going to go into fast Ethernet 1/6 on switch 2, switch port mode trunk. Now, just a side note, best practice in production, shut those ports down before you do a command like that. The reason why is because they may end up putting themselves in error disable mode, meaning there's an error on the port that it's not gonna work out right. So in this case, let me just bring this command prompt up because I want to see when it fixes itself. You can see that it has become a .1Q trunk, so the port is still up. Now I can verify that by doing a show interface fast Ethernet 1/1 followed by switch port. Did you see what just happened there? Yeah. Come on, applause, applause. We're pinging between our hosts. So what's happening behind the scenes is it says, I've enabled a trunk. By default, I'm going to allow all VLANs on this trunk. And currently, I have VLAN 5 as being an active tag trunk. Thus, our computers are able to ping each other on VLAN 5 over that trunk link. Now, all it will take to break it is coming to either one of those switches and putting one of those interfaces back in switchport access VLAN 1, or flipping it over to VLAN 10. You can see right there the pings time out because we're no longer able to communicate. One side's in a different VLAN. So as long as we leave them in VLAN number 5, then our communication will be just fine after everything switches back over, right? So that's enabling a trunk between those. Now, last thing I want to show you on the trunk side of things. By default, trunks carry all VLANs, which, as your network grows bigger and bigger and bigger, may or may not be what you want to do. A lot of best practice documentation from Cisco says, yeah, they do that. They carry all VLANs by default, but it would be good for you to come in there. And looks like it just picked back up on those pings. Good for you to come in there on those trunk ports and limit them down to how many VLANs they carry, and carry only the VLANs you want them to. So we can do a switchport trunk allowed VLAN, and we get to say, this is the list of allowed VLANs that I want to say. I want to see a VLAN 1 and VLAN 5 are the ones allowed across that trunk. You have to, bad VLAN, you have to include all, of course. It's saying you don't need to tell me one. One is by default there. So I'll say, that just wasn't what I planned on seeing. VLAN 1 through 5. Bad VLAN. You have to include, oh, this is one of those. Okay. Right about now. See, this is where Jeremy goes, I should have practiced this before we got in here. So ether switch modules use a different, kind of a little legacy version of the, let me show you the full status message right here. It's showing that you also need to include these default VLANs. Check this out. Do show VLAN-switch, right? These default VLANs, you can see they're unsupported, but they're there. Why? Because the industry standard documentation for VLAN says you have to have them there for token ring, for FIDI. I mean, these are technologies we haven't used for a long, long time, which is why they're unsupported. But nonetheless, on some old switch software, it says you have to add those in there. So I'm going to come in here and do a switchport trunk allowed VLAN. Oh, check this out. I'll do 1, 5, 1002 through 1005, right? There we go. Now it's isolating those down. Now, so which one did I not add in there? VLAN 10. So let me do this to the other side, and then I'll tell you one big catch that can nail you. And I'm going to tell you it's probably, I don't want to speak doom and gloom over you, but it's one of the, you remember in the Matrix, where Neo first gets sucked into the Matrix and he has to jump across the big building with the gap, and everybody's like, oh, it's Neo, he's going to be like the one, right? And he jumps and he falls like 50,000 stories and smacks onto the concrete, but doesn't die because it's the Matrix, it's not real, unless your body makes it real. But nonetheless, he jumps, and what's he say? Everybody falls the first time, right? So I will show you something, and I will tell you everybody falls the first time on doing this. So what we've done is we've gone in here and done allowed VLAN 1, 5, 1002 through 1005. The biggest mistake people make is, okay, so down the road, you want to start using that DSL customer too, right? Well, it's not added to the trunk. You've limited. You've said just these VLANs are allowed across the trunk. So you come in here at some point, months down the road, and you say, okay, I want to add VLAN 10. So you type in allowed VLAN 10. You hit the enter key, and what it does is strip off all of these guys and just replace it with VLAN 10 to where VLAN 10 is the only one that is allowed. Now, I will tell you, in this case, it won't because of this old flavor of software iOS where it's like, hey, that's a bad VLAN list. You have to include the default VLANs. And you'll probably go, oh, my goodness, I almost killed myself. But on a lot of the newer iOS versions, it will allow you to just say 10. It'll strip off all of them, which essentially causes a whole network outage. Like I said, everybody falls the first time. What you want to do is you want to go in and type in VLAN, switchport trunk allowed VLAN, add such a keyword. Add in 10. So we add that one to the list instead of replacing the list with the number 10. Did that help? Add that. So adding VLANs is always going to be done using the add keyword. If you want to remove a VLAN off, it's the same thing. Switchport trunk allowed VLAN remove 10. My brother getting into Cisco, that was the toughest thing for him to remember. He always was doing switchport trunk remove instead of switchport trunk allowed. So I talk and I talk and I talk, but you get the concept, right? That's the way that we create. So this is all layer 2. Layer 2 VLAN configuration. At this point, we're setting these computers up in a VLAN. So these two devices are isolated from the rest of the network in VLAN 1, but that's it. We don't have any routing to them. If they want to reach somebody in VLAN 1, they can't, because as of yet, there's no router to help them get there. So that's what we're going to get into in the upcoming nuggets. We're going to look at setting up a router on a stick, as well as doing layer 3 switching. I hope this has been informative for you, and I'd like to thank you for viewing.